This is session 433, Network Acceleration and Other NIC enhancements, networking enhancements for the data center. It's actually not just for the data center, it's for the enterprise. So, most of what we're going to talk about today does not exist in client or is not supported in client. So this really is a talk for those of you who are IT specialists, NIC vendors looking to populate NICs in servers. So hopefully that kind of sets the context. A couple other things, we will hold questions along the way at the end of the talk, which probably won't go the full hour, but we'll get close. We will have a group of experts here who can take questions on different topics. We're actually going to talk about 11 different technologies in the next hour. So we're going to be moving right through. We're not going to get deep on any of them, but we know that many of you are here and you want some questions that are deeper. And so at the end of the session, we will take questions either on the floor mics if you choose to, or if we get nobody at the floor mics, we'll go ahead and terminate the session and take them lined up here in front. Your choice. So obviously the first question that always comes up is, well, what's this session about? If you're a hardware vendor, if you're an OEM, if you're anyone who needs to know more about what networking is going to be in the next version of Windows Server 8, this is where you need to be. We're going to really work through what these technologies are. And of course, like all the sessions, all the slides will be online in a few hours, and so will the video. Gotta find the right button on the clicker here. So what are we going to talk about? What are some new network stack enhancements? Not every one of our enhancements is in the NIC. We've got a few that are above the NIC. How does Windows 8 use the latest hardware? We've been working with many of you, a lot of our hardware partners, to develop some new features. Not every hardware partner is developing all of these. We'd love to see every NIC vendor support every one of the NIC enhancements we talk about. Obviously, you're going to have to make the decisions for yourselves as to which customers you're trying to meet and which ones you think you can do best. So what are you going to leave with? You're going to get a big overview of all of these technologies. Not deep, but broad. And you're going to get enough acronyms that when you go down to the Ask the Experts meeting tonight or off to your next cocktail party, you can sit there and spout acronyms and sound like a networking expert, even if you can't remember, like me, what they all actually stand for. So, what do customers want? More performance, always. Of course, they want that with less cost. Yeah, that's a challenge, isn't it? And they're not willing to give up reliability. They always want good reliability. How do we do that? Hardware offloads are a great way to improve the performance of our servers. The more of your CPU power, the more of your specialized processing power we can pull on from the operating system, the more performance we can provide to the customer. The happier the customer is with your product and with ours. Of course, we have to do our job too. And so up above the NICs, up in the bottom of the operating system, we need to do our job of making sure that our networking stack is as efficient as possible and takes advantage of all of the clues and hints it can get to provide the best optimized experience for that customer. And so the whole story is, if we get improved network performance and reliability, that's going to drive greater workload densities and lower operational costs. That's what customers want. Better density, lower cost. So, here's the 11 topics we're going to talk about, divided into 4 groups. We're going to go through fabric convergence in the cloud. And there we're going to talk about DCB, KRDMA, DCTCP. We're also going to talk then about operations reliability, CDN, and NIC teaming. And then Michael Nanical is going to give us a demo of the new NIC teaming interface and what it can do. We're going to talk about flexible and secure clouds. We're going to cover GRE, IPsec task offload. And finally, we're going to get into 4 high-performance networking offloads: RSC, RSS, Dynamic VMQ, and SRIOV. Think this is enough for one session? There's 3 places we can get bottlenecks in the converged cloud. We can get them up in the host stack. So we've got to do our job to take care of that. We can get them down in the host NIC. Guess whose job it is to help us with that? Yours, yes. And we can get them in the network. And so we work with our networking partners as well and take advantage of the capabilities that they're offering. The 3 features that fit into this section of the talk: DCB, which is really about QoS and bandwidth management; DCTCP, about congestion avoidance; and KRDMA, which is about really fast transfers with very low overhead. When you're driving and you see a car at a stoplight a block in front of you, do you keep going at the same speed right up to the back end of it and then slam the brakes on? That's TCP's algorithm. And as soon as that car clears, it goes back to full throttle. Whoops, it caught up too fast because it wasn't moving away. By using the ECN bits that we get back from network switches, which most network switches today support, we begin to look at the amount of congestion that's starting to occur in a network. And we've optimized our stack to read that amount of congestion and back off just enough to be kind of like the driver who sees that car parked 2 blocks ahead at the stoplight and just lets off the accelerator just a little bit and coasts up so that as that car starts to move away, they can move in smoothly behind it. The pipe stays full. You're still getting everywhere you're going just as quickly, but you don't have to deal with all the brake wear and tire wear and acceleration and deceleration that you have to if you are reacting only in an on-off type mode. This does, as I mentioned, require ECN bits from the switches. But most data center switches today provide that. This also is designed around working within the data center. We actually detect very short round-trip times, and we only turn this algorithm on when we're encountering the very short round-trip times, because that's when it makes sense. What are the results? When we run straight TCP, we discover that our actual transmission rates go up and down, and the amount of buffer we're using then has to go up and down and stay large. When we turn on the DC-TCP algorithm and take advantage of those ECN bits, we're able to reduce the flow down to a very, very minimal buffering because we're not transmitting when we know there's congestion that's going to get backed up. So we have a very limited buffer per flow, and we still keep the pipe full, and we get just as much data through, and we can use shallow buffer switches, which cost less. Okay, another technology we have. One of those things which last night's party kind of reminded me of when I was standing there in line for the men's room and the ladies were just zipping right through our line and in and out, and unusual event. I'm told it's frequently Geek Fest, but I hadn't quite experienced that before. One way to deal with congestion and make sure that you don't block important flows with other flows is to assign virtual lanes to each flow, virtual amounts of bandwidth, to do bandwidth reservation by type of traffic. We call that data center bridging. It's a standard technology. This works by reserving bandwidth in the NIC. This is a NIC technology, and requires us to mark traffic by types of traffic, and then the NIC to help us to reserve bandwidth in the NIC for that type of traffic. This then goes out to the switches, and switches participate in this. We can operate even without participating switches. It's just not quite as effective or efficient, but we still can work it. This does require a couple of the specific RFCs to be implemented, actually the IEEE specs to be implemented. It doesn't require congestion notification. But if you have DCB turned on, we do get lossless transport of your major flows. One of my favorites was demonstrated the other morning at the big talk. And from where I was sitting, it seemed like most people seemed to miss the significance of this one. The person doing the demonstration pointed out that he was getting 2 gigabytes per second across the wire and using less than 1% of a CPU. Now, think about that for a minute. What kind of CPU would you normally expect to be seeing used if you were pushing 2 gigabytes per second? Yes, a lot faster. How do we do that? Through RDMA. RDMA allows us to write data directly to the NIC, where it's transported across the network and comes straight up on the other side, where it's placed directly where it needs to be. In Windows 8, SMB Direct is using this technology. Network Direct is using this technology. Everything that uses SMB, Hyper-Vs, Hyper-V over SMB, other technologies we've got going, some of which are not announced yet, are making use of this when it's available. Let's hold questions for later. So this is going to be a very important feature for low latency, high performance networking. We have a number of vendors who will be shipping this with us. We're hoping for more. And if you have more questions on that, we'll talk on it later. The initial testing saw some really good performance benefits from RDMA, and then of course the demo yesterday morning in the server keynote, 2 gigabytes per second at less than 1% CPU. And we're still working on optimizing this. We're not done yet. So reliability, a very, very important topic. We have 2 features here that we're bringing to you today. The first one is consistent device naming. How would you like it if every time you brought up a server on bare metal, the ports inside the system were named what they were labeled on the box? Would that be useful? I actually recommended to one vendor that they color code their ports so we could have a green NIC and a blue NIC and yellow NIC and a red NIC, because we all know every system needs a red NIC. But they didn't go that way. But you will see all of the major OEMs, it appears, are going to be shipping boxes that are CDN compliant. This does not mean that name can't be changed by the user or that persists or overrides a user's renaming of a port. It means that the initial name, when it comes up, out of the box, straight off the line, will be exactly what the manufacturer of the BIOS says that NIC should be named. We expect this will save a lot of effort on a lot of data centers. If you need to read more on this, the PCI SIG ECR reference is here. If you implement a VBD, a virtual bus driver, for your NICs, you need to talk to us, because you need to reflect some things up since you're hiding some of the PCI information from us. NIC teaming. How many of you have ever had to deal with NIC teaming on a customer? Is it one of your favorite topics? It's one of mine. Why? Well, because I think we finally have got this thing figured out, what we need to do. We heard from a lot of NIC vendors that they are tired of pouring engineering costs into something that they couldn't sell. Now, some NIC vendors have solutions that they believe are differentiators. We appreciate that. and there's nothing we're doing that blocks a customer from running a vendor's own NIC teaming solution. But if they choose to use the in-box Microsoft-supported solution, so they don't end up calling a NIC vendor and getting told, oh, that's a Microsoft problem, and calling Microsoft and getting told, well, turn off the teaming, it's the vendor's problem, then they can use ours. This is a V1 product. It's going to be very good. It won't have everything you've ever heard of in NIC teaming, but we think it has what customers need at this point. We call it the most popular feature in the data center because it turns out that in spite of the fact that Microsoft doesn't support third-party vendors' NIC teaming solutions, 70 to 80% of the servers that are out there today still run NIC teaming. It's that important to people and their workloads. Once they have a Microsoft-supported solution, we think it could go higher. We are completely vendor agnostic. We support teams of up to 32 NICs. And those 32 NICs could be one each from 32 vendors, if we could find 32 vendors. It doesn't matter. The features that we represent up will, of course, be very dependent on the features that the underlying NICs support. And all of it is managed through PowerShell or through a UI that is a front end for PowerShell. We do have multiple teaming modes like almost all the vendor solutions do. We work very well with Hyper-V. We work very well with native server. We support VLANs, all the VLANs you want. We do all the kinds of things that most of the NIC vendor solutions do today. And with that, I'm going to turn the mic over to Michael Nanicle for a few moments as he gives you a demo of that NIC teaming solution.
All right, thank you, Don. My name is Michael Nanicle. I'm a test lead in Windows Core Networking, and I'm very happy to be here today to give you a demo of the NIC teaming UI. So let me, I'll switch over in just a moment. Okay, so what you're looking at right here is a fresh install of a Windows Server 8 operating system. And the first place you would go to manage your server is Server Manager. So I'll go ahead and launch Server Manager. And right now I've selected Local Server. And here you can see that right front and center is NIC teaming. So from here you can click the link and it will take you directly into the NIC teaming UI. Now, first off, it asks you what servers do you want to manage. You can manage the local server that's pre-populated right here, or you can list multiple servers if you wanted to manage teams across your whole data center. So this is the NIC teaming UI. First, you'll notice a Teams dialog up top where you can select a team, or select a server. Servers dialog, where you can select a server. And we use PowerShell to build all this. This entire UI is built on our PowerShell commandlets. By selecting the server, you can see the available adapters that you can team in the network adapters and teams interface list. And then over here, you see I don't have any teams created yet. Now, all of the names that appear here in the network adapters list are the same names that would be named from consistent device naming. So admins won't mistakenly team adapters that are connected to different ports on the switch. They'll know exactly what adapters they're teaming. Now, to create a team, I'll come over here to Teams, click on Tasks, and select New Team. I'll just give it a name, and then scroll through the list of available adapters, find the ones that I want to team, and that's just about it. By default, the teamed interface is in VLAN trunk mode, but if I choose to, I can select a different VLAN. I can add multiple team interfaces later to have multiple VLANs. For now, I'll just go ahead and keep it default. Now, clicking over to Advanced, you'll notice that we have multiple teaming options. We have a switch-independent mode, static teaming, and we also support LACP. Static teaming and LACP are, of course, switch-dependent, and one would choose those if they want receive load balancing. I'm going to go ahead and select LACP because I know that the members that I've selected are connected to a switch that's configured for LACP teaming. The distribution mode, we have a couple of different types, address hash and Hyper-V port. Address hash, of course, will use TCP port number and an IP address to make sure that application workloads can be distributed across multiple members. Or Hyper-V port, which will make sure that a single VM's traffic flows over a single team member. So I'll go ahead and select address hash and click OK. Now sometimes the UI refreshes a little bit faster than our team actually gets created. So a quick refresh shows that everything's online, the team is OK. And if I scroll down here, you can see that the LBFO demo team that I've created now has 2 members on it. Selecting one of these interfaces will also show you statistics that can allow you to diagnose or troubleshoot or monitor any of the servers or any of the teams that are in your data center. Now what I'm going to do next is simulate a failure for one of these adapters. And I'm going to do that through PowerShell and demonstrate a little bit about some of our new PowerShell commandlets. So we have a set of commandlets called netadapter that you can use to disable or enable or manage any other feature on your network adapter. These are the same types of features that you would see in the device manager advanced properties, now are fully manageable through PowerShell. So I went ahead and disabled LBFO member 1. And going back to the UI, doing a quick refresh, you can see that it tells the server administrator that this server has a warning, that the team on this server has a warning. And then if I scroll down and look at the interfaces, you can see that this one is disabled. The same thing would show here if it was a link failure, if the network cable was unplugged, you would see a fault. But I just simulated it by disabling the adapter. So I'm going to go back and enable the member, refresh the UI, and you can see querying online, the team is good, and everything seems to be pretty happy right now. Scrolling over here to the team interfaces, this is where you would add an additional interface to the team if you wanted to add an additional VLAN or additional teamed NIC to expose to the OS. For now, I'll just leave it the way it is. So that's pretty much the teaming UI. I've just showed you how to create a team using available members using this list. What I'm going to show you next is something that we did here within Microsoft when we created the Windows Server 8 NIC teaming feature. We went ahead and looked at all of the advanced features, a lot of the other things that Don has been talking about that network adapters support, features like RSS and RSC. And we tried to figure out intelligently how we can support this through our teaming solution. So what I'm going to do next is run this simple little PowerShell script. I'm going to get the netadapter RSS properties of my LBFO members. And I'm just going to set a static IP address on the team just so the demo will work. So I'll just disable DHCP and set a static IP. So what I want you to notice is that these 2 different members have a different number of receive queues for RSS. So this shows that we're teaming a heterogeneous set of NICs with differing capabilities. One of them has 4 queues, and the other has 2 queues. And what we did in NIC teaming is found a way to aggregate all of these RSS queues, such that if I generated some traffic, you'll see receives being distributed across 6 different CPUs. So to demonstrate that, I'm going to bring up Internet Explorer, and this is a saved view into perfmon, looking at some of the per processor receive indications for the team NIC. And what these bars represent are different CPUs where traffic is coming. So if I run this little script to receive traffic, and this is just NTTDCP, what we should see are 6 different bars showing us that we're receiving on 6 different CPUs. And looking at the new version of Task Manager, you can see that we're aggregating the bandwidth of our 2 1 gig NICs to the full 2 gigabits. So that's the demo. Thank you very much.
One of the advantages, of course, of having a teaming solution from Microsoft is that it's built in the same team that builds all of our other networking features. And so you can reasonably expect that it's going to work with our networking features as quickly as we bring them out. One of the challenges that customers have had with some of the vendor solutions is that Microsoft would roll out a new technology, and the teaming solutions would be a year or 2 years or sometimes longer behind in getting there. We know it's hard because we don't always tell you what we're going to be rolling out, and it can take time to get that built in. We appreciate our partners a great deal. So, moving on to the next set of topics, clouds must be flexible and secure. 2 topics we're going to talk about. One of them was talked about earlier today, isolation of private networks through Hyper-V virtualized networking. And the other one, IPsec task offload for VMs. How many of you have attended the Hyper-V virtualized networking session? Some of you? You got a deeper dive than I'm going to do here today. So you've already seen this slide and heard most of this. You're all aware that VMs can be virtualized, that we can take physical machines, virtualize them, stick them all in one piece of hardware, and to the person running in the VM, they look just like a piece of physical hardware. We believe you should be able to do the same thing with networks. Traditionally, this has been done through use of VLANs. We find that VLANs don't scale, especially not to the size of hosters. We found some other issues that we had to deal with. And so we have come up with the Hyper-V virtualized networking solution, which uses a technology called generic routing encapsulation, GRE. GRE is an industry standard. We do it in accordance with the standard, and one of the things we're really looking for is support for GRE in NICs. Now, why is this important to us? Today, if I do encapsulation, and I still want things even as simple as technologies that virtually every NIC supports, like address calculation, it doesn't work because I've encapsulated that packet deeper in, and the NIC doesn't know how to look for the headers it needs to do address calculation on. So we're looking, so the result is that the GRE can affect performance, and we can't get some of the other NIC offloads that we want from those connections. So if we can get GRE in the NICs, a GRE offload, such that the NIC can do the address calculations on the internal packet and do the other offloads as they affect the internal packet, both inbound and outbound, then we can get performance up to the level that we really believe is important for our customers. There's 2 RFCs that tell us how we do this. We do IP rewrite, and we really want, as it says, we really want NIC vendors to be supporting this. If you think this is something that your NIC could do, talk to us. We'd like to hear more. We'd like to talk to you more about how we can work together. Another technology that's very important to us and very important to our customers as they try to meet the requirements of Sarbanes-Oxley and HIPAA and the other requirements that are out there for securing data communications and securing customer data and customer personal information all the way end to end is IPsec task offload. IPsec is a technology that you've heard about from Microsoft for a long time. It's something you know we believe in very deeply. We also know that like any kind of technology that does the security transformations on the data, we're going to have to get hardware support to be as quick as we really want to be. Today, there are some NICs that do IPsec task offload. We like that. We like that very much. What we've done in Windows Server 8 is extend the ability to get the advantages of that IPsec task offload, not just for native workloads, but also up into the VMs. The Hyper-V switch manages and distributes the SA slots across the VMs so that VMs can get the ability to offload their SAs into the NIC as necessary. We have 4 more technologies to cover. These are specific things that we're working, we really are enjoying in the new networking stack. These are ones that give us some really good performance. SRIOV. This is a technology many of you may be familiar with. It allows us to actually get direct placement of data between the NIC and a VM. This provides for some very good bandwidth optimizations and CPU use reduction. The VM network then completely bypasses the host stack to get into the VM and vice versa. It does require, obviously, chipset support, both in the BIOS of the host as well as in the NIC. And it requires some virtualization help. Now, there's a couple of things about SRIOV that occasionally come up. One of them is that we don't support teaming of an SRIOV NIC when it's in SRIOV mode. The reason is that if the data is not flowing through our stack, we can't fail it over. If it's going direct from the VM to the NIC, it doesn't pass through our teaming stack. And so obviously, that's going to be an issue if we were trying to team it. Not all customers care about teaming. Some of them want the performance benefits of SRIOV. Receive segment coalescing. RSC is a very important technology. It is very similar to the large send offload that we've been supporting for a long time. RSC allows the data to come in and for the NIC within an interrupt cycle to coalesce the arriving packets so that they then pass up through the stack as a single TCP packet. This is, of course, again, very useful for reducing the processing of the headers. The most expensive part of processing incoming traffic is processing the packet headers. And if the more of that we can offload into the NIC and let the NIC do it, the better off we are. And so we get no additional delay because we're only doing it within the interrupt cycle. Only things that arrive between the interrupts get coalesced. And then it comes up as fewer packets into the host OS. Initial testing indicated 10 to 30% performance improvement. We've still got some tuning to do. We'll see what it looks like when we're ready to ship. Receive side scaling is not new technology. RSS has been around for a while. However, we're now dealing with machines with much larger sets of processors than we were 5, 10 years ago. We weren't talking too much about NUMA and K groups and terms like that when RSS first came out. Today we do. So RSS has been enhanced to support cross K group operation, multi-NUMA node operation. We spread these interrupts across a much broader set of CPUs. And of course, as it's been from the beginning, administrators can go in and say, no, I don't want them spread on these CPUs. I don't want these used for networking. So they can set the set of processors that will be used for RSS. The other thing that's changed is that in Windows Server 2008 R2, RSS only applied to TCP traffic. We now support it across UDP as well. So incoming UDP packets will now get the same benefit. And finally, dynamic VMQ. VMQ, of course, is not new either. It was available in Server 2008 R2. A big change from Server 2008 R2 is that we now dynamically look at what streams are using the queues, and we will rebalance the use of the VMQs that are available based on what streams need it, which VMs need it. So if a VM that's been quiet and didn't have a queue suddenly becomes active, the Hyper-V switch will look at that and on the VM's behalf provide a queue for it. Even if it means taking another VM's queue that had been busy earlier and is now more idle away. That wraps up our presentation. I told you we'd be done early. Let's walk through the review of it. Our goal, as always, improving performance and reliability, reducing costs for the customer. This is the key thing we're always trying to do in the networking group. Better performance, better reliability, lower customer costs. Making use of the new and improved hardware offloads to get to that higher performance. Making changes in the networking stack to improve performance there as well. And providing functionality like NIC teaming that customers want for reliability. We believe that Windows Server 8 is the best OS out there today for the cloud and data center. I think you've heard that message repeated at the keynotes and the other sessions. It is something we believe. So, what are your next steps? The customers are asking for better network performance. Come with us. Deliver these features with us. Make them available so customers can get access to them. Customers will do refresh on their hardware if they believe that there's a cost benefit to doing it. IHVs, you're our partners. Come along. OEMs, we want you too. We want you to be specifying that your providers need to deliver these kinds of features because your customers care. We have a series of related topics. Of course, I think with the exception of one of these, they've all been done or are going on in parallel. But you can always go back to the Build website, download the slides, look at the videos, get the information. There's a lot of networking stuff going on right now. Hyper-V networking, the Hyper-V network virtualization. Look through these. And then, of course, for general networking questions, we've always had the alias up, and we continue to Indus6FB, Indus6 feedback at Microsoft.com. Send us email with your questions. Thank you.